Hello and welcome everyone. My name is Dane Menke. I am the Digital Marketing Manager here at Regenesis and Land Science. Before we get started, I have just a few administrative items to cover. Since we're keeping this under an hour, today's presentation will be conducted with the audience audio settings on mute. This will minimize unwanted background noise from the large number of participants joining us today. If the webinar or audio quality degrades, please try refreshing your browser. If that does not fix the issue, please disconnect and repeat the original login steps to rejoin the webcast. If you have a question, we encourage you to ask it using the question feature located on the webinar panel. We'll collect your questions and do our best to answer them at the end of the presentation. If we don't address your question within the time permitting, we'll make an effort to follow up with you after the webinar. We are recording this webinar and a link to the recording will be emailed to you once it is available. In order to continue to sponsor events that are of value and worthy of your time, we'll be sending out a brief survey following the webinar to get your feedback. Today's presentation will discuss evolving remedies to achieve successful site closure at brownfield sites. With that, I'd like to introduce our presenters for today. We're pleased to have with us Joseph Good, Associate at Langen. Joe Good is an environmental engineer with over 17 years of experience working on both national and international projects. His technical work focuses on environmental assessments and client support under numerous state and federal regulatory programs. Joe Good's extensive consulting experience includes everything from initial site assessment and due diligence support through remedial implementation and site closure. He has a Bachelor of Science in Civil Engineering from the University of Illinois, a Master of Engineering from the University of Canterbury in Christchurch, New Zealand, and is a registered professional engineer in Illinois, New York, Michigan, Missouri, Iowa, Indiana, and Minnesota. We're also pleased to have with us today Maureen Dooley, Vice President, Industrial Sector at Regenesis. Maureen has over 25 years of experience in many aspects of the remediation industry, including project management, research and development, senior technical oversight, remedial design, and laboratory management. In her current role at Regenesis, she provides technical leadership for complex soil and groundwater remediation projects, including groundwater contamination treatment for PFAS, chlorinated solvents, and petroleum hydrocarbons throughout North America, as well as remediation design, strategy, and business development. All right, so that concludes our introduction, and now I will hand things over to Joe Good to get us started.
Thank you, and hello everyone. Thanks for joining me and Maureen today. I'm excited to talk with you about a couple of sites that I've worked on with Maureen to address both more traditional contaminants and petroleum and chlorinated solvents, as well as everyone's favorite topic over the last couple of years, PFAS. While I'm in Chicago now, I was in New York City for the first 15 years of my career, and the talk today includes a couple different sites in New York, and then one that's just getting out of the ground in the greater Northeast. I love working with Regenesis because, one, they're very smart and have a slew of products that deliver consistently, but more than that, when things don't go according to plan, they're right there with us in the trenches, helping deliver alternative paths forward to meet with our client and regulator demands and expectations. With my presentation today, I stay out of the weeds and instead take a high-level look at a few different sites. I'd be happy to follow up with you on any specific questions about any of the sites, but I wouldn't do them justice to go into too specific of a deep dive on any one of them. I'm still delivering the message about evolving remedies to achieve successful site closure at brownfield sites. I'd like to acknowledge that all the projects took a full team approach, and it's not just me taking all the credit up here. Jason Hayes, Vinicius DePaula, Stu Abrams, Amita Oka with Langen did lots of the heavy lifting, as well as Maureen, Todd, Glenn at Regenesis, who were key team members on the various sites. Getting first into the background and the objective of the talk today, we know that even the best laid plans can go awry. We take our time, we carefully pick where each of the investigation points is going to go. And over the years, we've gotten better. We apply the latest science to treatability studies and pilot studies to make sure that the investment in the investigation is reasonably in line with our desired outcomes. Technologies keep getting better and better. Our engineers and scientists keep getting smarter and smarter, and we all march out into the field with our perfect conceptual site plan And inevitably what happens is things don't go according to that plan. Field complications are unavoidable. And some of the best talks and experiences within the industry that I've had are where the smartest people in our industry tell stories about how things didn't go quite right. And we can all learn from them. And that's sort of the intention of today's presentation. The first site I'm going to talk about is in Queens. It's a 27,000 square foot garage. It was a former industrial manufacturer for more than 80 years with lots of leaking petroleum tanks. I think some folks maybe don't understand Queens, or they think it's the suburbs. And so what I'm actually showing here is a picture at the time when this first went into manufacturing, and you can see it's completely built up from lot line to lot line with everything from multi-story residential to dense industrial developments. Similarly, on the bottom picture, Queens and specifically Long Island City is extremely urban, which complicates the remediation in many cases. We did our remedial investigation through the New York State Brownfield program and identified chlorinated VOCs in groundwater. We had PCE detected at 490 micrograms per liter. However, an on-site source was not immediately apparent, and identifying a clear off-site source in this dense urban landscape was difficult. A huge premium was placed on schedule and addressing on-site contamination as a volunteer in the New York State Brownfield Cleanup Program, and that was greatly preferred to the time lost trying to identify off-site sources and then chasing the money to potentially pin someone down for a fraction of the overall responsibility. The initial plan was to hog out petroleum contamination because groundwater was pretty shallow and easily accessible. There was minimal LNAPL, but we agreed to take that out, and we were going to treat the dissolve phase chlorinated contamination through an injection program. Again, plan properly, go out, do a lab treatability study, and feel pretty confident starting with your remediation. The baseline conditions in groundwater here, maximum CVOC concentration of 607 micrograms per liter, of which PCE was at 490 micrograms per liter. Total CVOC concentrations tailed off to the southwest as you go down gradient. I highlight this groundwater flow direction here because even on these smaller, tight New York City sites with all the utilities and preferential flow paths, the groundwater flow plays a critical role in the remedial design, which you'll see on the next slide. So here's a snapshot of the treatment we designed and implemented. 25 injection points with 2 different injection doses based on the contaminant distribution at the site. You can see we put them in rows. We applied both plume stop and HRC. Roughly 10,400 pounds of plume stop and almost 1,000 pounds of HRC in the high dose areas, which are the darker blue. And then we also injected another 6,800 pounds of plume stop and 1,000 pounds of HRC in the low dose areas. So we injected quite a bit of product here. And we ran into a few typical injection findings when we were forced to address in the field. We had previously not been overly concerned with the geology as it was unconsolidated fill over sands, but we were getting tighter matrices in the field than we originally anticipated. We were able to pivot and slow down the injections and where necessary, relocate the injection volume to the highest subsurface contaminant concentrations. And that generally worked pretty well across 90% of the site, but there was an isolated location near the highest concentration where we didn't get great contact and distribution, and we needed to go back and direct mix a couple of trenches, which I'll show you what we did here. MW10 was the highest concentration prior. We had lots of injection going in above and below it in the lines of injections that we had, but we then went, because time was so critically important, we had to improvise on the go, and we put another 800 pounds of plume stop, 100 pounds of aqua ZVI, and 80 pounds of HRC in 2 up-gradient trenches shown in gray. And the results looked great. A quick look at our CVOC results for this one shows a declining concentrations across 2.5 years. and I'm happy to report that the concentrations remained near non-detect and subsequently quarterly monitoring. The initial decline, we think, was some synergy with the initial NAPL and petroleum hotspot excavations that happened in conjunction with the remedial injections. The first injection took care of most of the issue, as you can see in all the wells that dropped in concentration. And then the second direct mix pivot took care of the rest. The need to drive these low concentrations was from New York State Brownfield cleanup regulations, and we didn't really have time to wait to see if concentrations would come down. So we were pretty proactive with that additional trenching exercise. Overall, a great story. It needed a little extra push to get across the line. The site has received its certificate of completion and closed out through the Brownfield cleanup program. And I didn't show the additional quarters of monitoring, but it continued low, and we are no longer monitoring this site after a number of years. Jumping into the second site, we step over to Brooklyn. Again, a brownfield cleanup program site with tanks galore. I think we pulled something like 30 tanks from this site, which was a little bit less than 30,000 square feet. It had a little bit of everything, with the primary goals focused on addressing CVOCs and BTECs in groundwater and soil vapor. As you can see, the soil vapor number is screaming, and just to put it in context, these properties were being redeveloped for residential use. We had a combined treatment approach that started out straightforward, and then we had to evolve, like most sites, as the client came back to us and told us we had half the time to address the subsurface contamination. We had a good bench scale treatability study that showed base activated persulfate was going to work really well on our contaminants. And then we elected to add plume stop to the treatment train when we were informed that the building was going to go up right over the contaminated areas much faster than originally anticipated, and we wouldn't have access to come back. In addition to the plume stop belt and suspenders approach, we also included a sub-slab piped network. So stepping through the remediation here, we had almost 12,000 pounds of sodium persulfate and 20,000 pounds of sodium hydroxide initially to knock down the petroleum area. And then we constructed over 5,000 linear feet of horizontal well network and injected plume stop for a little bit of the residual petroleum, but mostly for the CVOCs. We put in north of 50,000 pounds of plume stop via the well network, and then another 15,000 pounds via a direct push method. And the results were great. Regenesis would probably hope that I pause on this slide, but everybody can clearly see what's happening here. Almost everything came out of solution and stayed out of solution for a site closure really quickly. Another look at the same results, and I want to highlight here that the rules of the remediation changed. We had half the time and no ability to come back if the remedy didn't work. So like I said, we added the plume stop and the pipe network at a significant cost to ensure that the outcome was in line with what we needed. The cost in this instance was worth it for the peace of mind, and we were able to realize significant tax credits through the Brownfield program. A major point, I guess, in both this site and the first site that I talked about was they're a little bit older, and we used injectable carbon. And call me skeptical, but I'm always concerned that the carbon might not be able to hold the contaminant long term. But I'm pleased to say that years down the road, these sites were still, contaminants were either completely degraded or still absorbed to the carbon. So I know that studies are starting to show that, but I wanted to emphasize the fact that these are two real world examples where I was initially skeptical. Regulators are skeptical to a degree, and we're seeing real data come back many, many years down the road showing the same absorption. So the third and final site that I wanted to touch on is a site in the Northeast. It's a little bit of a stretch because it's not technically a closed site, but it fits into the story of staying nimble on brownfield sites, and it includes our favorite topic in PFAS, so I threw it in. The site was a former firefighting test area. It's huge at 200 acres, and there's elevated contamination across more than a third of the property. The source area was identified with a private firefighting test area where they would light product on fire and put it out. But there were also many other contamination areas where the source is less clear cut, much like a lot of the PFAS sites that folks are dealing with. In this case, we had PFAS detected up to 4,600 parts per trillion, and there's really challenging subsurface geology. I put the picture of the lasagna on the side because that's representative of the glacial till with the intermittent beds of high and low porosity. I don't mean to dumb it down, but that's what I think of when I kind of see these different lenses of high permeability and low permeability on top of each other. We're in the early stages of completing the pilot study to optimize the ROI, the injection pressures and volume, but this one is different than a lot of the other contaminants we've done pilot studies for in the past, and we needed to change our mindset when addressing it. PFAS does not behave like some of the more traditional contaminants we've been working with for the last 20 or 30 years. The injectable carbon was always a contact sport, but with PFAS at such low concentrations that we're trying to reach, it's also so much more recalcitrant than petroleum or chlorinated solvents that you need to approach the remedy as a whole and inclusive of the pilot study in a different vein. So we completed our first pilot study phase. There's going to be multiple phases of this, and it included about 2 drums of plume stop, which was diluted into about 800 gallons of solution. That was injected across 6 injection points, and we were looking at the distribution extensively, both in wells and in soil cores that we collected. And we weren't just looking at whether or not there was staining of the soil or whether there was plume stop identified in the wells, but we were trying to use other tracers to ensure that we got penetration into the entire soil matrix. And that's been really hard, but with such low concentrations that we need to hit, the contact sport, as mentioned earlier, is that much more important. In addition to the visual inspection that's commonly done on more established contaminant remediations, we are also taking an analytical evaluation, which was driven both by the regulators. I think it will be good to have a look at the hard numbers, but again, it's a lot more investment up front for a much more recalcitrant and difficult contaminant to handle. So lots of differences between the traditional or CVOC pilot study and PFAS study. We're really excited about the possibility of using injectable carbon in this case, but it's going to be a tiered pilot study approach until we can get comfortable with the injection area, and then we'll proceed full hog. I put the picture of the bullseye here because sometimes people think about an injection program as a ring of concentric circles representing the radius of influence. But in the lasagna type case that we have here, it's anything but that. And you have product squirting in all sorts of different directions as you apply even low pressures. So trying to get a real handle on that is the key of our first phase of the treatability study. And then the second picture here is a Regenesis image, but it gives you a little handle on what that injectable carbon looks like. Sometimes people think of it as, sand-like or sludge-like. It's almost ink-like, and that kind of shows the scale of the injectable carbon within plume stop and how it's able to disperse through the matrix. With that, those are my 3 sites I wanted to talk on briefly. I'm happy to turn it over to Maureen Dooley for a couple other slides and discussion.
Well, thank you, Joe. That was a really interesting presentation. And I always really appreciate the opportunity to work with Langen as a team, but Joe specifically. And we've had a number of really great projects. And, I'd like to point out, he's mentioning the urban environment and the 5 boroughs specifically. So if anyone has ever had the opportunity or chance to work in the 5 boroughs, you do appreciate the absolute challenges that you're confronted with. And it can be access, things like that for the environmental application, but it's also things like, where am I going to park my car? And so Langen and folks like that are really nimble, and they know how to address these challenges and just do such a great job with these brownfield redevelopment. So anyway, on to what I'm going to talk about today. So I just want to follow on with Joe and get a little bit of a kind of a high level look as well, just talking about brownfield, but also getting into some of the technologies and scoping and some important things to consider. But, we talk about brownfield funding, really for all of us environmental practitioners, the real estate transaction, the brownfield type work is really a key component of, what we do as a business. And it's really good to see that, we've got through the infrastructure law funding that's coming through EPA. And I know specifically for this year, they're talking about 169 million in this revolving fund and cleanup grants, and I think a lot of this is going into the municipalities. But another important component of brownfield is the state programs. In New York State has always had a very robust brownfield program, as well as states like Ohio and across the country. And I think overall this objective is to really spur growth in these communities with this new development. And I'd have to say, over the years, seeing the results of these brownfield projects, they've really have changed communities, for the better and been really important. So what I want to talk about, getting into the environmental side, looking at what are technical site objectives, and Joe's mentioning that to get certain credits, you may have to have a very specific objective. And it's really important to know. I mean, it can be anything from just looking at mass reduction, or do I really have to stop the offsite migration? Do I need to meet a really stringent regulatory standard, or am I just transitioning to M&A? The vapor mitigation component, is vapor an issue? What do I need to do to address that? And then the emerging contaminants, and how do they impact this program and this project? And just going back to Regenesis and what we provide, we have a wide range of products that can be used for a range of contaminants. We have our services group, and we also are able to provide solutions for vapor mitigation, specifically vapor barriers. And, you can look at this figure with all these sorts of products and you say, oh my gosh, what am I going to use and where do I need it? And I just want to kind of go back to this original issue when you're defining it and scoping it, and some of the things that you want to consider. So with any plume, you have, I say, we saw the core area first, but, in looking at the plume that you need to address, you may have a source, a core, and a dissolved area. And the technologies you use to address any of those individual areas may vary. And typically in the higher concentration zones, you tend towards physical chemical. As the concentrations start to decrease, you may be looking more towards chemical biosorption type technologies. And then when you're getting to the very low concentrations, dissolved plume, the idea of bioremediation and sorption take an even bigger role. So each of these technologies have a different sweet spot. I'm sure people have seen these types of graphs before. And, if you're looking at the high concentration mass reduction technologies, things like ISCO, of course, are used quite readily. You can also incorporate, even with DNAPL sites, you can start looking at the ISCR bio combination to get at some of that NAPL for things like petroleum hydrocarbons, when you're getting to very high concentrations, petrofix, and some of that sorption. And we also do have stabilization technology specifically for some of the emerging contaminants like PFAS, where we can use some of the absorption technologies. And then on the low end, when you're trying to reach these very low concentrations, bioremediation tends to be the more economical approach, or bioremediation combined with sorption. And there's a wide range of products and materials that you can look at, for your consideration. And so what I want to do is just touch on different types of sites, again, very briefly, looking at the mix of materials that may be used to achieve these goals. One that we had in New York State was also a New York State Brownfield project. It was a complicated site in that we had TCA DNAPL, and there also were PFAS. And so we needed to have a program for that. We were able to very successfully use our persulfox ISCO product to reduce, TCA, which was as high as 132 ppm, 60–90%, also reduce 1,4-dioxane. But we also were able to install a barrier in the bedrock using plume stop colloidal carbon along with sulfadated ZVI as a cutoff for PFAS and chlorinated solvent migration. And we were able to achieve a 90% reduction, and that's all we really needed. And given that sort of site and site objectives, we were at mass reduction and able to get the certificate of completion. On another site, this is one that was one of the biggest train depots in Europe. And this is a remedial strategy where they went through this whole process of physical, chemical, biological with the utilization of a multi-phase extraction to deal with LNAPL, transition into ISCO, finally using Petrofix and ORC. So you're using chemical sorption, biological degradation. And again, using that combined strategy, you're able to achieve very significant reductions and meet the objectives of this particular site. On the low end, when you're trying to get very low regulatory goals, is some of the sites that Joe was referring to, and specifically looking at chlorinated solvents. If you employ the colloidal carbon in the plume stop, or plume stop combined with HRC, or maybe now our Aquafix, what you're able to do is get a very rapid reduction. You can meet those targets quickly, and then these targets are maintained. And this is critical when you're in a real estate transaction where time is money. So your ability to achieve low targets in a short period of time may be part of a critical path for you and your client. And then what about PFAS? Like Joe said, you can't have a talk without mentioning PFAS. And it's important to think about, you might be in a state where data is being collected and people are looking at PFAS. You may be in a state where they're just starting that collection and they may not be requiring any treatment, or you may be in one where they're not doing anything yet, but it's still something you have to think about because PFAS isn't going away. New York State, I think, has been a little ahead of the curve in the sense that they've been collecting data, and in some locations have required some remediation, and we've been involved with it, I'd say at least 3 sites where PFAS was considered and the technology was targeted to address PFAS as part of the remediation. And we have not had the soil cleanup yet, but we anticipate that that may be part of upcoming projects. So again, just to remind folks that if you're concerned about PFAS as part of your program, we have technologies that can address either soil contamination and looking at a stabilization sort of approach, and that would be an alternative to offsite disposal. So that way you're not worrying about liability in future years, you're able to stabilize on site. And then we also have obviously the plume stop to deal with groundwater and mitigate any offsite migration. Example of the types of data you can get, if applied properly in putting things where they need to be and you get those injections the way you want them, these are the kind of data that you can get where you can have, again, achieving low levels very quickly. So really in closing, I just want to emphasize the importance of thinking about what your objectives are. And with Regenesis, we're here to walk through with you during site evaluation, technology selection, and product implementation. Obviously, we'll be there in the field, and we're going to make sure these materials are applied in the right way. And we may have to pivot based on what the conditions are. And we're also there at the end as part of the evaluation. And this is, I think, an example. We've had this type of relationship with Langen, and it's one that we've always appreciated. But I think at the end of the day, when we're all working together and talking and putting all of our best efforts forth, we're there to try to meet those objectives of your clients in the most cost-effective way we can. So with that, I'm happy to get into questions.
All right, thank you very much, Maureen. So that's going to conclude the formal section of our presentation. Now at this point, we'd like to shift into the question and answer portion of the webcast. Before we do this, just a couple quick reminders. First, you will receive a follow-up email with a brief survey. We really appreciate your feedback, so please take a minute to let us know how we did. Also, after the webinar, you will receive a link to the recording as soon as it is available. All right, so let's circle back to the questions here. This is a question for Joe. Joe, the question is, what would you have done differently if you had a chance to go back and start from the beginning?
So we've been doing remediation for many, many decades, and like I showed in my presentations, and I'm sure Maureen would vouch for it, things always change in the field. So you can't go back and say, oh, I wish I had more data. We already have orders of magnitude more data to make our decisions with today than we did before. But I think I would set expectations with newer clients or less experienced clients that things are going to change, and we're going to be able to work through them, and we're going to come up with a solution. But on day one, when you're looking at it or you're completing your remedial investigation, you aren't going to know what that's going to be. You might have a general sense of what it looks like, but you need to establish those expectations that it's going to be a process, and we can work with you to get there in the end as a team. But don't expect that the first thing that's drawn up on the plan that gets approved by the regulator is going to ultimately be the final solution.
All right, thanks, Joe. So here's a question, and this one's for Maureen. Maureen, the question is, have you received a certificate of completion at any sites with PFAS?
Oh, yeah, that's a good question. Actually, we have. I think I know of one specifically out in Western New York where we put in a plume stop barrier that was specifically for PFAS, and we did receive that certificate of completion.
All right, so here's another question for Joe. Joe, the question is, how can lessons learned here be applied to other urban remediation projects to produce similarly favorable results?
Right, so I think having contingencies in place is the key to ultimately getting closure. The one site we talked about had 2 sets of contingencies and an additional chemical application, and then the pipe network underneath the building in order to get you to the concentrations that you need to ultimately get to obtain closure. So I think it's building in contingency and building in redundancy in the remedial approach is the best way to have a positive outcome going forward. I think it was Matt Burns talking about, we pinch pennies all over the place through value engineering exercises, but making sure that you have the spacing tight enough in your injections, making sure that you have enough chemical or the appropriate amount of chemical going into the ground is, pennies on the dollar when it comes to having to go back in and reopen stuff up and losing time and function of your building. So be conservative and build that into your assumptions.
All right, thanks, Joe. So here's another question for Maureen. And Maureen, the question is, if PFAS is present and determined to be a contaminant of concern, how does this change your design?
Yeah, so if you've got PFAS as part of a program, and let's say for the sake of argument, this is a combination of chlorinated solvents. Like say you have a site where I'm initially looking at TCE, DCE, something like that, and say, oh wow, we just looked at this PFAS and the state says we have to include that too. So what we want to do is we want to make sure we have, a technology that can address both of them. So if PFAS is part of it, that's going to have a colloidal carbon aspect or component of this design. So for us, we need to look at, okay, now that we have PFAS, this isn't something that will degrade. We have maybe a co-contaminant. We're going to need to run a specific, models for us to make sure we have the correct loading to address the PFAS. Because it's one thing when we're designing a barrier, for instance, or an application to address chlorinated solvents, we're going to have a degradation component, and our targets may be low part per billion, but now we're in the nanogram per liter zone for PFAS. So our barrier or a plume stop application is likely going to be more robust because it's not as forgiving. We're not going to have the degradation component. We really have to have that sorption. So if we are going to include PFAS as part of a target contaminant and for remediation, we may have to adjust our loadings for a plume stop barrier to make sure that that's addressed.
Okay, thanks, Maureen. So here's another question for Joe. And Joe, the question is, you talked about 3 different sites here that each had an injectable carbon remediation, although in different applications. Do you see PFAS as categorically different than the chemicals we've been treating over the past 20 to 30 years?
Yeah, so it's inherently different. It's inherently more difficult to deal with. Carrying on from what Maureen was saying, the remedy looks a little different. You might be using some of the same tools, but they're being implemented in different ways. If we're really going to get down to these part per trillion levels, then it's going to look different. But I think that the tools that we have in place and the technology is catching up with where our sampling has been the past few years, and there are remedies. It's encouraging to see that you've closed sites out. I think, when people are talking about PFAS, very few people are talking about active remediation of PFAS, and Regenesis has it under their belt. Langen's done several remediation of PFAS sites to date, but there aren't that many of them. So I think that the remedies are going to continue to evolve, similar tools, but through a completely different lens, both in the need for contact and in the low concentrations that regulations in some places are driving.
All right, thanks, Joe. So, and then speaking of contact, here's another question for Maureen. And Maureen, the question is, are there new tools used for PFAS site characterization to improve the contact sport?
I'm going to say it in 2 ways. Now, there's the contact part of it, but I also just on the design side, one of the key components is really understanding the flux into a zone. Where's the contamination? What's the flow? So we do have our flux tracer tool, which we're able to use to kind of get the vertical delineation and pinpoint where we need to apply. And then when we're doing the application, we have a process that we've developed to confirm the actual injection radius of influence and those sorts of things. We have this design verification process. And so what we'll do is when we we'll have an injection, we'll maybe put in temporary well as grabbing cores, so we can confirm that the plume stop or the colloidal carbon has distributed where we want it to, and we may need to make those adjustments. And this is, again, getting back to what Joe is saying, as we're getting into these lower targets, and this can even be with the chlorinated solvents. Like if you really want to, achieve that, to get that other layer level for your, tax credits, to be able to achieve that, we have to get that distribution, of the reagent. So it's really critical to take the time to make sure that you're looking for verification that we're getting things where they need to be. Again, as you referred to, Joe, take that time, make sure it's in there, and have, you're talking about contingencies, but even when you're in the field, to ensure that you're getting that in placement, and then that's going to give you the highest probability for success to meet your client's objectives.
All right, thanks, Maureen. So here's another question for Joe. Joe, the question is, are you concerned about contaminants, PFAS or others, desorbing from the injectable carbon long term?
Yeah, so I tried to make that point, and holistically, yes, I'm nervous about it. I am environmental engineer at heart, and it's math and science, and especially with PFAS, you aren't getting the destruction as quickly as you are with some of the other contaminants that would absorb the carbon. But I'm very optimistic that in the data that I'm collecting and responsible for, and the people that are collecting it for me that I am vouching for, that it's been very promising. It's not desorbing, and the arguments just from a straight science perspective will always be out there. But the proof's in the pudding. We have multiple sites that have not experienced rebound or desorption rather, and I anticipate that a similar trend will be true for PFAS. We will see at the part per trillion sort of concentrations what that looks like, but I think as we embark on remediations of PFAS all over the place, we're going to be tackling the largest, nastiest, highest level concentrations first. And in those instances, I'm less worried about desorption of PFAS from the colloidal carbon.
Well, Joe, I'm glad to hear that you're confident, and I'm glad to see the results have been working out the way they have. And I guess just to kind of add on to that, one of the things that we've done is, we've have these models that we've been running, to provide, predictions, but, it takes time until you see the data. And one thing we've gone back and tried to, calibrate these models, and they typically are running pretty close. Like we go back so many years out, are we seeing what we expect to see? But again, it's always encouraging and exciting really to see that these sites are maintaining as designed and will continue to do so in the future.
All right, thanks, Maureen. So here's another question for Joe. Joe, it's kind of a two-part question. Regarding the remediation at the PFAS site you talked about, what was driving the remediation at this site? Was it a redevelopment? And are the PFAS projects you're seeing mostly phase ones?
So I guess start with the first part. What I'm seeing driving remediations are the major exposure pathways to human health and the environment. We are not at the stage where we're regulating all sites with PFAS above 4 parts per trillion. I know that there's regulations that are eminent. They've been eminent for a while, but we don't have the capacity in many different ways to go about treating every site that has that kind of level of contamination. But we are seeing some of the major emitters and the major exposure pathways being addressed. So I would say that that's what we're seeing right now. And then as far as what's driving that, some of it's regulatory driven, some of it's transaction driven. It sort of depends. While we are not seeing PFAS in written documents on every property transaction, it is, in my experience, discussed behind the scenes and considered on all property transactions. And I think that that's kind of the prudent way to approach it. If you stick your head in the sand and say, it's not legally required, or I'm not going to do this, both on the buy side and the sell side, I think you aren't going to get very far in that transaction. I think it needs to be on the table. I think it's the way the industry is headed. And I think it's also a driver for remediation if identified through the property transaction.
All right, thank you very much, Joe. So that is going to be the end of our chat questions. If we did not get to your question, someone will make an effort to follow up with you. If you'd like to learn more about environmental services from Langen, you can visit langen.com. If you would like to learn more about remediation solutions from Regenesis, please visit regenesis.com. Thanks again very much to Joe Good and Maureen Dooley, and thanks to everyone who could join us. Have a great day.